So this video is going to wrap up Friday's lesson on 2.4 and focus on 2.5. So 2.4, we were almost done talking about it. We just needed to talk about how to verify if two sets are equal. So the verification of equality of sets. So for example 3, they want us to determine whether, actually let me go to the next slide. Determine whether A intersect B complement is equal to A complement union B complement for all sets A and B. Well, we can do this with Venn diagrams. So we'll do a Venn diagram for the left side of the equation. And we'll check to see if it's equal to the Venn diagram on the right side. Whoops, A complement union B complement. So we got A and B, region 1, 2, 3, 4, and the universal set. And A, B, region 1, 2, 3, 4, and the universal set. So to think about the left-hand side, I kind of want to focus on what's in the parentheses first. So I sort of want to think about what A intersect B looks like. Well, A intersect B is here in this intersection, right? It's region 2. It's where they overlap. It's what they have in common. So if we want the complement of that, we want everything in the universal set that's not this. So let me take away all my scribbles. So since it's everything but this, it is all of these regions. And usually underneath they'll write the regions that we highlighted. So it was region 1, 3, and 4. And then I wanted to do that first. And on this side, we want to think about what A complement is. Well, that's everything that's not A. The whole universal set, but not A. So that's A complement. And B complement is everything that's not B. And we want to union those. So why don't I use different colors? Green right now is B complement. And red is A complement. Everything that's not A. And if we're putting it the union, within A complement's bringing all of its stuff and B complement is bringing all of its stuff, and they're going to start their house together. So it's all the stuff that we shaded green and all the stuff that we shaded red. So as you look at the chart, there's nothing that isn't shaded red or green or both. So it's actually all 4 regions. So now when you just compare their regions, these should have, give me a second here. I see my mistake. Maybe you saw it faster than me. There is a region here that isn't shaded by red or green. Region 2. Region 2 isn't shaded at all. So now when you compare the regions for the first Venn diagram and the regions for the second Venn diagram, they are equal. So we just verified that this and this are equal to each other using Venn diagrams. Okay, to do section 2.5, it's applications of sets. I really need you to pause the video and find your book and open it to page 75 so we can look at example 1 together, because it's just too much stuff to write down in order to do the problem. Okay, So, trusting that you have example 1 open on page 75. Let's read it. At Erie Community College, a survey was taken to determine where students studied on campus. Of the 250 students surveyed, it was determined that 167 studied in the library, 138 studied in the cafeteria, 75 studied in both the library and the cafeteria. So we need to make a Venn diagram for this. So we'll get it started. I forgot about the circle tools and the rectangle tools. All right, so I've got my universal set, region 1, 2, and 3. Oh, I should have talked about why I just needed 2 sets. It's because we're just talking about 2 separate things, the library and the cafeteria. So set A, it's got a special name now, it's the library. And set B is the cafeteria. And what you want to do is you want to figure out the intersection first. So read through the problem and figure out which number is dealing with both. Who studied in the library and the cafeteria. So it said there were 75 people that studied in the library, both the library and the cafeteria. So we put that there in the intersection. So that 75 is already counted in the library circle, and it's already counted in the cafeteria circle. So then if we just focus on library, it says that there were 167 that studied in the library. So in this full circle, there should be 167, but we already have 75 there. So we're going to have to do 167 minus 75 to figure out who else studies in the library. So these people only like to study in the library, and these people like to study in both. Okay, 92. And now let's figure out who else is in the cafeteria. There are 138 who like to study in the cafeteria. Well, we already have 75 people in the cafeteria circle. They're already counted in this 138. So we have to subtract and figure out that leaves 63 people who only like studying in the cafeteria. Okay, and just to double check yourself, if you added up that entire cafeteria circle, the 75 plus the 63, you would get the 138 that studied in the cafeteria. Okay, the last thing we need to do is figure out who all is in the universal set. And if you reread the problem, it said in the paragraph part, of the 250 students surveyed. So the universal set is 250 students total. Well, the universal set is this whole rectangle and includes everything in it. So we're already counting the 92 from the library, the 75 from both, and the 63 from the cafeteria. So we need to add those up. So that's 230 people that we've already accounted for, and there were 250 people total that were surveyed. So we'll subtract those to figure out that there's actually 20 that don't study in either place. Maybe they study in their room. All right, now if you'll turn your page to example 3, we're going to do the same thing with 3 sets. It's on page 77. So we'll go ahead and get it set up. I gave it away a little bit. I'm telling you already that we're going to use 3 sets. These aren't exactly evenly spaced. 1, 2, 3, 4, 5, 6, 7, 8. Universal set. Okay, hopefully you're looking at page 77 with me, and we'll just read through example 3 together. Liberty Travel surveyed 125 potential customers. The following information was obtained. We're going to go kind of fast through this. 68 wished to travel to Hawaii. 53 wished to travel to Las Vegas. 47 wished to travel to Disney World. 34 wanted to travel to Hawaii and Las Vegas. 26 wanted to travel to Las Vegas and Disney World. 23 wanted to travel to Hawaii and Disney World. And 18 wanted to travel to all three. Make a Venn diagram for that. So that was a lot of information. Now we're going to go through and think about what region we need to fill in first. And when we did just sets with numbers the other day, we looked for numbers that were in all three of the sets so that we could fill in region 5. So that's what we're doing. Well, first off, what are the 3 sets in this problem? It's the 3 places we traveled to. They mentioned Hawaii first. I'm going to make that be A. Doesn't really matter. Then they mentioned Las Vegas. So for me, that's the B circle. And last, they mentioned Disney World. So that's my C circle. So I'm looking for the people that wanted to travel to all 3 spots. And that would be the very last line they gave. 18 wish to travel to all 3 destinations. So we're going to put 18 in that region 5 overlap where all 3 circles overlap right there. Now we just have to remember 18 is counted in each of those 3 circles. So now maybe next we should do the overlaps, like maybe we should look for the Hawaii-Las Vegas overlap. So if you look through the information, Hawaii and Las Vegas, it says 34 wanted to go to Hawaii and Las Vegas. So I need 34 here in this overlap, but we already have 18. So 34 minus 18 is 16. So we have 16 there in that overlap. And then we want to look at the Hawaii and Disney World overlap, which is this whole region. And remembering we already have 18 in that. So Hawaii and Disney World was 23. 23 people wanted to go to Hawaii and Disney World. We already have 18. So we're going to subtract 18. Let me get rid of this yellow. It's not the friendliest color to use. 23 minus 18 is 5. So there's 5 in that region. And then we have another overlap area between Disney World and Las Vegas. 18 people are already in that overlap. Who else wants Disney World and Las Vegas? 26 want to go to Disney World and Las Vegas. That's 26 total. We already have 18. So that means 8 are right there. Okay. And then this, region 1, is, well, the circle for Hawaii is all the people that chose Hawaii. And the information in the book says 68 wanted to go to Hawaii. Well, we already have 5, 16, and 18 people in the Hawaii circle. We need to add those up. 39. So we already have 39 people that we know of. We need to subtract that from 68 to see who else is in just the Hawaii circle. 90 minus 9. 29. So that means there were 29 people that weren't interested in other trips. They just want to go to Hawaii. There were 16 that want to go to Hawaii and Vegas, 18 that want to go to all 3, and 5 that want to go to Hawaii and Disney World. But if you add all those Hawaii people up, it should equal that 68. Then you do the same thing for Las Vegas. Las Vegas, it's talking about 53 people want to go to Vegas. Whoops. I didn't mean to do that. $53 people want to go to Vegas. Well, the Vegas circle already has 16, 18, and 8 people in it. 14, 22, 42. So we're going to add those up and then subtract to figure out there are 11 people that only wanted to go to Vegas. And then lastly, for Disney World, there were 47 people that wanted to go to Disney World. But that included everyone that's already in the Disney World circle. So we had 5, 18, and 8 people already in the Disney World circle, which is 31 people. You're going to subtract that from the 47 that were interested in Disney World and get 16 here. Okay, so you've got a few problems to try with this application idea, and I will see you Wednesday.